Okay, this is chapter 14, lesson 3. And I'm going to go ahead and tell you here at the beginning, we are not going to do everything that is on this page. Okay. Strange times. And so I think the last thing we need via distance learning is to be talking about the sine and cosine ratios that allowed us to develop or derive this particular formula for the area of a polygon. Okay, we're going to stick to our most important parts, and then if you really want me to walk you through all of the steps that he gives of how we derive this formula based on these triangles, I will be happy to do that over Zoom. Okay? So let's just focus on this for right now. We said before that when I have a regular polygon, I can divide that regular polygon into equal triangles, congruent triangles all around. Okay? And since I know how to find the area of a triangle, and a regular polygon is composed of triangles, through multiplication, I can then find the area of the whole polygon. Okay, pretty easy, right? Okay, so then it's just going to depend on what information we have. Okay, do I have the apothem, which would be awesome because that's the altitude or the height of my triangle, which is always useful when I'm finding area. Okay, do I have the base, this side here? Do I know that? Or do I have the radius, which we saw in the previous one when I was trying to find perimeter, that if I have the radius instead of the side length, it's a little more complicated to figure out the perimeter, but it can be done. Okay, so we also said that one reason we might care about being able to find the area of this polygon using the radius is how that connects to circles. Circles don't have side lengths. They don't have an apothem, but they do have a radius. And so this is one way that I can connect the two. Okay, so we can use sine and cosine to help us find missing parts. This we know is a 90-degree angle, so we have nice right triangles to work with. And we said this angle is pretty easy to find because we know that all around here is 360, and then we just divide it up by the number of triangles that you have. Okay, so I can find this angle, and so if I know my radius and I know this angle, I can use cosine to find my apothem, and I can use sine to find my base. Sorry. Okay, so given just the radius and this angle, I can find both the altitude, the height of my triangle, and the base of my triangle. And we all know 1/2 base times height gives me the area of the triangle. And so together that actually gives me everything that I need to find the area of not only this triangle, but by continuation the entire figure, since it's just a whole collection of congruent triangles. Okay, so all of this over here is just saying that. Okay, so don't get too worried about that. All that is saying we're going to take the parts of this triangle and use it to find the perimeter of our polygon. And then we're going to boil it all down into this little formula here at the bottom. A equals mr squared. Okay? And just like we said with our perimeter formula, we want to look at how this relates to the area formula as we know it. Pretty similar, right? Okay, so here's an example here of a dodecagon. Okay, a dodecagon has 12 sides, and so we're going to plug in 12 for n in all of these places. Okay, so when we go through and plug in 12 for n through this formula, okay, 180 divided by 12 is 15, so just sine of 15 times cosine of 15, okay, all that times 12, and that gives me 3. So when I have a dodecagon, a 12-sided figure, the area of that dodecagon is 3r squared. Well, think of how close that is to the area for a circle, pi r squared, knowing that pi is 3.14159, etc. So what your homework here is going to do is have you try out some different values for n, okay, and see what that is going to do to these values here, and see how that is going to get closer and closer to pi. Okay? Let me know if you have any questions on the homework. We'll go over those questions in Zoom. But this covers lessons 1 through 3 now, which is everything that we'll cover for Tuesday. Thanks.